Okay. So last time we did Egyptian multiplication, Egyptian division. We are going to talk about Egyptian fractions first, and then we'll go back to division and divide the ones that don't divide evenly. And then we're going to talk about different ways to decompose fractions. So
I have a
Egyptian
question about the
fractions or
homework.
the problem for Egyptians, other than just their like number system. So the idea of Egyptian fractions are, I got my pen and everything. They only used unit fractions. So what's a unit fraction? What does unit mean? What number? One. There you go. So unit fractions are fractions with one on top. So Egyptian fractions. They only used, oh, I said I'd bring white paper. I forgot. Unit fractions. So again, unit fractions are have a numerator of 1. And the reason why they did this is because of their notation. So if they wanted to show 1/2, and they would represent their number of 2, which would be 2 sticks or whatever version of they were using at the time. And they would put a dot on top. It shows a fraction. So that's why it had to be a 1 on top. It's because there wasn't really a way to show a 2 on top or a 5 on top or whatever. So yeah, 1/5 would be a 5 with a dot, so on and so forth. So if they needed a fraction that didn't have a 1 on top, they would write it as a sum of fractions. So if they needed a numerator greater than 1, they would write the fraction as a sum of fractions. And here's the other thing. If they have 3/5, they wouldn't write that as, how would you write 3/5 as a sum of fractions? Yeah, that's how we would all do it. 1/5 plus 1/5 plus 1/5, right? That would be, is that better? It's about that. That would be the easiest way to do it. But they wouldn't repeat they wouldn't repeat a fraction in a sum. So they would not repeat a fraction in a sum. So instead, so they wouldn't do this. Instead, they would write it as, there's lots of different options here. So for 3/5, you could write it as, I think this is the way they actually wrote this one, 1/3 plus 1/5 plus 1/15. Which if you put that in your calculator, 1/3 plus 1/5 plus 1/15 gives you 3/5. Another way to write this is you could also write it as 1/2 plus 1/10. And in a little bit, that's what we're going to spend today doing, is learning how to write fractions as a sum of unit fractions with 1s on top. So this process is called decomposing fractions. I think I mentioned that last time. And we don't know why they did this. We don't know why they wrote it as a sum, and we don't know why they wouldn't repeat it. But this is like what contributed to their fall, because they were not able to move very far in mathematics because their fractions are the ones that kind of messed them up. Let me see if I can make this brighter. There's a setting. Oh, there we go. That's so much better. Can you see that better now? Okay. Okay, so one nice thing about this is, so this seems dumb. Would you agree? There is a practical advantage to it. So let me show you, this is on the Ryan papyrus. There's this one word problem and it kind of actually makes a little more sense here. So the problem says, 6 loaves divided. Nope. Let's try that again. Divided among 5 men. Nope, 10 men, sorry. I don't know where 5 came from. So if I was using, card. And I hate not being in my classroom, because I really need scissors right now, that's okay. So if I had 6 loaves of bread, here's my loaves of bread, 2, 3, 4, 5, 6. Okay, so here's my 6 loaves of bread. So one way to do this would be, the way that we would do this is take this, split it into 5 pieces. No, sorry. 6, how would you do this? These 6 loaves, how would you divide this among 10 people? They each don't get 1, right? Probably what we would do is 6/10 reduces to 3/5. So each person gets 3/5 of a loaf. Agreed? So the picture of that would be, I need to take each of these cards and divide them into 5 pieces. And first guy, if I, tore this, if I had my scissors, I'd cut it. The first guy gets, I'm actually going to tear it and see how well this goes. First guy, the guy gets, here's your 3/5, right? And then I gotta do the same thing here. I'm gonna do it with all of them. So all of them get, oh, I'm not that strong. I overestimated myself. Let's try that again. So let's say this is 3/5. So here's my 3/5 for those. Here's my 3/5 for these. Not perfect, but you get the idea. So here's all my 3/5, agreed. And this is 2/5 left over. So here is, I have 10 people. 1, 2, 3, 4, 5, 6, get that full amount. And then now these leftover pieces are going to go to the last 4 people, right? This is 2/5. So I need to split this one in half to get 3/5 now, right? So on and so forth. There's my 7th person, 8th person, 9th person splits 10th person, right? That's a big old pain in the butt. Agreed. So instead, it was saying, this 3/5, if I wrote it as a sum of fractions, 1/2 plus 1/10, that means everybody gets half a loaf and then 1/10 of a loaf. So that would be easier to split up of your 6 loaves. 3, 4, 5, 6, because then you take, that would be 5 of the loaves, split them in half, right? So everybody gets half of that, split this into 10 pieces, and everybody gets 1 piece of that. So it's an easier way to split it up is the idea. So that was a word problem or an example that was in the Ryan papyrus, and it showed the answer was this, and that makes more sense for that word problem. So that's kind of the practical advantage of that. So a huge chunk of the Ryan papyrus was a table for the decomposition of 2 divided by a number. Okay, so if I wanted to take some fraction, 2 divided by some number, and rewrite it as 1 over something plus 1 over something, and maybe I needed a couple more of those. Okay, so rewrite it as a sum of unit fractions. There is a whole process. So like looking at the way they did it, there is a whole process for doing this real fast. Here is like the table. This is in the textbook. So 2/3 was 1/2 plus 1/6. 2/5 is 1/3 and a 15, 2/7, so on and so forth. And then like when you get down to the bigger ones, 2/29 was a 24th plus a 58th plus a 1/174 plus 1/232. Like that would be really hard coming up with on your own. And so think about doing fractions, like if you're doing work and you end up with 2/19 as your answer, you have to refer to this table for this. And think about how many tables you would have to have, because then you'd have to have the tables for 3 over something, a table for 4 over something. So that's the reason why they did not move forward very far in mathematics, specifically because of the notation, right? Not only did they have terrible non-positional non-place value like writing, but then this is how they did fractions. So this is what really hindered the Egyptians, was the fractions. So we have a couple of ways to do this process, okay, to break apart a number with a numerator that doesn't have a 1 into a sum of fractions with numerators of 1, okay? One way of doing this, and this is supposedly the way the Egyptians did it, is called the splitting identity. And it says that if you have some fraction, this splitting identity, what I'm about to write, starts off with 1 on top, but I'll show you how that would help us in a minute. So the splitting identity says if you have some fraction 1/n, you can break that apart into 1/n plus 1 plus 1/n times n plus 1. So let's get the hang of this first, and then I'm going to show you how I can use that for this version of the problem. So if I have 1/2, I can rewrite 1/2 as 1/n plus 1 would be 3. So 1/3 plus 1/2 times 3. So 1/2 is the same as 1/3 plus 1/6. Okay. Similarly, like let's do, I don't know, 1/8. That would be 1/9 plus 1/8 times 9. So 1/9 plus 1/72. So the way this works or is helpful to us for if it's a number on top other than 1 is if I had the problem 2/n, I could rewrite that as the idea is that's the same thing as 2 times 1/n. Agree? Yeah. So then the idea is the formula is just 2 times 1/n plus 1 plus 1/n times n plus 1. So this is one way to do it. I'm going to put a star by it so I can kind of refer back to it. This is one way to do it. There's other ways to do it, and we're going to go over all the ways today. So this is one way to do it. So for example, if I had the fraction, so this is an example,
Is this the way we figured out how they're doing it, or is this what they were doing?
Let's do this and let's look at yeah, it is. Because look, 2/3, well, we haven't done that one yet. We haven't done 2s yet, but give me a second, we'll do some. Let's do 2/3 instead of 2/9. 2/39. Do 2/3 first. So the idea is it's 2 times, what would the first fraction be? 1/4, because I add 1 to my denominator, plus 1 over the current denominator times plus 1, 3 times 4. And then when I multiply, 2 times 1/4 would be 2/4, which reduces to 1/2. This is 1/12. 2 times 1/12 is 2/12, which would be 1/6. And we're gonna be doing this a lot, so let me kind of help you especially with our bigger stuff. The idea is when I multiply by this by 2, those both reduce to 2 and a 1 on top. And then when I multiply this by 2, I can reduce the 4 again, 2 and a 1 on top. So this is now 3 times 2 on bottom of 6.
You do it with every number, like you do 3.
Yeah, we're gonna do that in just a second. Make sense? And this is 2/3 is 1/2 plus 1/6. So we don't actually know if this is the exact idea of what they're doing, but this is the answer they got every time. So we think that's kind of the idea. Because again, we only have a table with the answers, not the work on it. Okay, so that's an example of 2/3. Let's do the 2/39 now. So that would be 2 times 1/40 plus 1/40 times 39. So this is the ones where I really want to reduce before I multiply it all out, or else you're spending a lot of time on your calculator. So when I multiply by 2 here, like when I'm distributing my 2 in, is the idea. The 2 on top and the 40 on bottom, those reduce to be a 1 and a 20. Over here, the 2 on top and the 40 on bottom reduce to be a 1 and a 20. So the answer here would be 1/20 plus 20 times 39, which is 780. If you have the number 2, this process will always work. Why will this process always work with the number 2 on top? Because here's the idea, you have 2 options. With the 2 on top, your denominator is either an even number or an odd number. If it's an even number, it reduces and it becomes a 1, right? Like 2/40 automatically reduces to 1/20. If it's an odd number, when you add 1, it becomes an even number. So you're going to have something that will reduce with the 2 on top. So this works for every version of 2 on top of the fraction. In just a second, you're about to see where we're going to put a 3 on top, and it's not going to work with every version. Okay, so this will always work if there's a 2 on top. This is one way of doing it. I feel like this is the easiest way with the 2 on top. There actually is another way of doing it. So here's the other. I'm actually going to start a new page so I can like refer back to pages. Here's the other way of doing it. So the other way of doing it would be 2/n. Think about that as 1/n plus 1/n. If it's 2/15, that would be 1/15 plus 1/15. Agreed. You're allowed to have one of those. This second one becomes the problem. Agreed. So you could take that second one and write the second one as 1/n plus 1 plus 1/n times n plus 1. So let's do an example of that. So an example of that would be if you had, let's do 2/15. 2/15 is 1/15 plus 1/15. I'm allowed to have one version of the 1/15, right? This is the one that I need to break up now. So I'm gonna write it like this. This part equals 1/16 plus 1/15 times 16. So my sum would be 1/15 plus 1/16 plus 15 times 16 is 240. 1/240.
Okay, wait, so you said earlier, if it's even, if the denominator is even, how does it work?
Let me do one where it doesn't work first, and I think it's gonna answer your question without me having to like really use words for it. So let's do, let's do, yes, 3/13. Okay, if you can write, this one's not gonna work, the way I'm about to do it's not gonna work. So feel free to write this or just watch if you want to, if you don't want the wrong thing in your notes. So if I did this the same way I did the 2, I would write this as 3 times, break it up. It would be 1 over n plus 1, 14, plus 1 over 14 times 13. Everybody tracking? So now when I go to distribute the 3, I put a 3 on top here. Does that reduce? You get 3/14. And here, when you distribute the 3, you get 3 over whatever 14 times 13 is. 182. Ooh, 182. Which technically is this 2 fractions? Yes, but the end goal is to get a 1 on top. Do I have a 1 on top? So this would not be the correct answer here. Does that make sense? So the reason why it works every time with 2 is because when I end up here, I always have an even number on bottom. It's a 2 on top it's reducing with. But once it's a 3 on top, it's not working like that anymore.
You're saying that the denominator, if it's 2 on the numerator and the denominator is even, it should be like 1/2. And then
It'll already reduce. We don't have to do this. If it's an odd, then it will reduce when you get here. So it only works with 2. So we have some options if it's something other than a 2 on top. So one way to do it would be, there's 2 different ways to do this. Let me see if I had a preference here. Oh, that's a long one. Okay, so 3/13. There's 2 other ways to do this. One way to do this is, I'm gonna do the awful one first, so that the easier one is something you'd rather do. Okay, so 3/13 I could write as 1/13 plus 1/13 plus 1/13. This is awful. Fair warning. You're not gonna like it. Okay, so, and I'm allowed to have one of them. This is gonna be part of my answer at the end. These 2, I can't have. So I need to do the splitting identity on both of them. Okay, so this one would turn into, my 2 fractions would be 1 over 14 plus 1 over 14 times 13. Agreed? And this one is going to be the same thing. 1 over 14 plus 1 over 14 times 13. Go again. So at this point, my answer for 3/13 would be 1/13 plus 1/14 plus 1 over, it was 182, 13 times 14, plus 1/14 plus 1 over 182. I'm only allowed to have everything one time. So this one's done. This one's done. This one's done. I can't have those 2. So I got to do it again for both of these. So 1/14 would split into 1/15 plus 1 over 15 times 14. And this one's the super big one, 1 over 183 plus 1 over 183 times 182. Sorry, they got really small. So my answer would be, I still have the 1/13. I still have the 1/14. I still have the 1 over 182. Now I have a 1/15. And then 15 times 14 is 210. So 1/210 plus 1/183, and then 1/33,306. Got to be a better way, right? And imagine if that was 7/13. Think about how many pieces you would have at the end if you did it this way. So questions about that before I show you the other way? Get the idea of it? Okay. The better way to do that is instead of splitting 3/13 into 1/13, 1/13, 1/13, let's split it into 1/13 plus 2/13. The reason why I did this is because this one's already done. And now this is with a 2 on top. So when I split it one time, it's going to automatically like reduce out and work itself out. 2's on top is like where it's at. Okay. So when I go to break this apart, this now becomes a 2 on the outside with 1/14 plus 1/14 times 13. And when I distribute the 2 in, you get 2 and 14 reduced to 1 and 7. 2 and 14 reduced to 1 and 7 again. So it's still 1/13 at the beginning. This first fraction would be 1/7. And the next fraction would be a 1 on top and a 7 times 13 on bottom, which is 91. Isn't that better? And this idea kind of works with the bigger ones too, for like 5/13 or 6/13 or 7/13 or 8/13. And you can be very thoughtful, like you kind of have to think ahead in the problem, but you can make it work out this way. Okay, so let me show you that.
Like if you had 6/13, but you're not saying
A 2, a 2, and a 2.
one, you have to have 1/13 and
Sure.
you just fill the rest to, I guess you. would have-
Well, then you'd end up with this again, a 1/7 and a 1/91, and you'd have to break that down. So let me show you. So what if I, instead of 3/13, let's do 9/13 this time. And I picked this number on purpose. So 9/13. So I don't really want to do 1/13 and then 2, 2, 2, 2, 4, 6, 8, 2, 2, 2, 2, right? Because then I would end up with these 4 break into 8 things, and those 8 things all match. And then I'd have to break those more and more and more. So we're going to think ahead. I want to break this apart into some addition of fractions. It doesn't have to be 1 plus 1 plus 1. It doesn't have to be 2 plus 2. It could be 3 plus 6. It could be 4 plus 5. It could be 7 plus 2, like whatever makes 9. Would you agree? So I'm going to be thoughtful with my fractions, and I'm going to think about whenever it breaks down, it's going to be a 14 and it's going to be a 14 and a 13. What are my factors? I don't have factors of 13. What are factors of 14? 7 times 2. Does 7 plus 2 give you 9? Yeah. So I'm going to break this into 2/13 plus 7/13. And the reason why I picked 2 and 7 is because here in a minute, when I distribute the 2 in and when I distribute the 7 in, they're both going to reduce. Does that make sense?
Yeah,
Let's do
it
it.
actually does, yeah.
So I'm gonna put the 2 on the outside of that one. And then I'm gonna put the 7 on the outside of this one. 7, and it's 1/13. Oh, sorry, 1/14 plus 1/14 times 13. So you see where we're headed here? So when I put the 2 up here, I'm distributing the 2 in. 2 and 14 reduced to 1 and 7. This 2 and 14 reduced to 1 and 7 also. So I still get 1/7 plus 1/7 times 13 was 91. Processing Adam. So that I don't end up with 2 over 14 times 13. What is that? 2 over 182 and then have to reduce that. I can do this. I'm reducing before I multiply it all out. In my head, I can do this in my head and the other half on my calculator, and it bugs me to have to type crap in my calculator. Here when I distribute the 7 and 14 reduce to 1/2. Put 7 here, that also reduces to a 2, and 2 times 13 is 26. So this is plus 1/2 plus 1/26. And that's 4 unit fractions that all have different denominators. So this method you have to think about, but I would rather think about it instead of having to do 1/13, break it down, and think of how many answers you would have there. So let's do a couple of those. So if it was 5/17. Now that I'm sitting here and saying this kind of reminds me, when you factor and you have to figure out the factors of this that add to give this. This is kind of what that is. Because the idea is the number I want to work with is not 17, it's n plus 1, which is 18. So I want to take 18, factors of 18 are 1 and 18, 2 and 9, 3 and 6. Kind of the idea.
You wanna do,
None, 1 and 18, 2 and 9, 3 and 6 don't, but you can add any combination of those.
you wanna do.
You want to do the 2 and the 3.
Hmm.
Because 18 is divisible by all 6 of these numbers. So you want to do any combination that adds to give 5. So I want to break up 5/17 into 2/17 plus 3/17. And sometimes with the numbers, you could have lots of different options. Like if this was actually a 19 here, this was 19, whenever I break down 20, I could do. No, I need to come up with a better example, but sometimes there's like 2 options here and it doesn't matter. You can do either one. So when I go to do this, Oh, this is 7/17, sorry. 2/17.
2/17 and 3/17, those are in the answer, no? Or only when they get broken down?
They're gonna get broken down. So the 2 is gonna be on the outside of the first one. Of 1/18 plus 1/18 times 17. And then a 3 on the outside of the same thing. So I'm going to distribute the 2 in on top. I get 2/18 reduces to 1/9. And this is 1/9 times 17. So I would get 1/9 plus 1/17 times 9, 153. I want to distribute the 3 in. I would get 3 and 18 reduced to 1 and 6. So I get 1/6 plus 1/6 times 17. It's 102. Oh, here's the next problem I have. There's two ways to do this one. Questions about that? Good with that? Let's do one more of those. This problem, if I have 7/11. The idea is I want to take the number 12 and plus 1. What are my factors of 12? 1 and 12, 2 and 6, 3 and 4. What combination adds to give you 7?
3, 4.
You got two options. One of them is 3 and 4. What's the other option? You can also do 6 and 1. If you do 6 and 1, you don't even have to break down the 1 with a 1 on top. So it's going to be two different answers, but they're both correct answers. So if you did it as 1/11 plus 6/11, 1/11's done. I don't have to split that one, right? And then this would be 6 times 1/12 plus 1/12 times 11. And when I distribute the 6 in, 6 and 12 reduces to 1 and 2. So you get 1/11 plus 1/2 plus 1/22. What do you think, Adam?
Pretty good.
Good. In my notes, I did the 3 and the 4. Here's it worked out with 3 and 4. You do 3/11 plus 4/11. You have the 3 and the 4, and you get 1/4 plus 1/44 plus 1/3 plus 1/33. So if you add these on your calculator, you get 7/11 regardless. It's just two different answers for it. Okay, questions about that? Okay, let's pause. Let's go back and do a division problem that doesn't divide evenly. And think through the fractions on it. I also want to see if I had one written down that does not divide evenly. So let's see. If we had, oh, here we go. 51 divided by 12. So do we need to review division before? Okay, so let's review regular division. Let's do one that works out nicely. Let's do. I'm making up a problem. Let's do 816 divided by 17. This one divides evenly. So this is where I take 17 and I double it until my right side adds to be 816. Okay, so one set of 17 is 17. Two sets of 17 is 34. 4 sets, you're doubling the number above it, would be 68. 8 sets would be 136. 16 would be 272. I think I need to go one more up. 32 would be 544. Is that right? I'm gonna do my calculation.
Just trying to get the 17 or-
Trying to get to 816 on the right-hand side. Yeah, 544. And we need some combination over here that adds to be 816. So it'd be 544 plus. Is that big, too big? 544 plus 272? Plus 544 is, oh, there you go. 816 exactly. 2 plus 4 is 6, 7 plus 4 is 12. Carry the 1, you get 8. So these two add to give you 816. So my answer would be 32 plus 16, which is 48. Questions about that? Okay, so let's do one that does not divide evenly. Let's do 51 divided by 12. So doubling 12 to get to 51. One set of 12 is 12. Two sets of 12 is 24. Four sets is 48. I don't want to go bigger than that because I don't need to. So 51 is 48 plus, there's nothing smaller, right? So what you can do is go the opposite. Instead of doubling it, you can half it also. So half of 12 is 6. Half of 1 is a half. If one set is 12, then a half of a set would be 6. That's still too much. So let's half it again. Half of 6 is 3. Half of a half, 1/4. And 51 is 48 plus 3. So my answer would be 4 plus 1/4.
Oops.
Does that make sense? Um. You can actually, do that a different way. Oh, no. Sorry, different problem. Let's do a different problem. Let's do 53 divided by 12 this time. The same thing, 112, 2, 24, 4, 48. I'm gonna use the 48. How much more do I need to get to 53? I need 5 more, right? I'm not gonna get, if I half and half and half, I'm not gonna get to 5, right? I'm not gonna get a set of 5. So instead I need to get 2 fractions to add together. So instead of 5, I could get a 4, right? Can't I break 12? Like to turn 12 into 4, I'm dividing by 3. I'm not like halving anymore. I'm like doing it in thirds now. So 1/3 would be 4. Now, how much more do I need? 1, which would be what fraction of 12? 1/12. So in this case, 53 would be 48 plus 4 plus 1, which would be 4 plus 1/3 plus 1/12. And again, this seems dumb to us, but this is how they wrote their fractions, 1/3 plus 1/12. Questions about that? Look at,
Why is it 1/12 and not 1/4? Because you're going back from 1.
if I'm 4 divided by 4 gives me 1, so 1/3 divided by 4 gives me a 12.
Okay.
If for me, it's easier just to go off of this one. To turn 12 into 1, I need to divide by 12, so it's 1/12 of 1. But you can, use the one before it to get there. What if, there might be a situation, I was trying to not do another example, but what if there was a situation where you needed like 2 of these and you didn't have a way to get it any other way? You couldn't write it as 1/12 plus 1/12. You'd have to break apart 1/12 and do like the splitting identity at this point. Okay, so is this version of fractions fun? No, it's not fun. That's the thing is that's really the reason why the Egyptians, did not do well in mathematics is simply because of, their number system, but also with their fractions, like it really held them back. There is one other way to break apart fractions, and this is not from the Egyptians, but since we're here, we're gonna go ahead and talk about the other way. It's called Fibonacci's method, okay? And we will learn all about Fibonacci in a while, in a few weeks. But this is another way to decompose fractions. So this is a different method for decomposing fractions, and it's called Fibonacci's method. The idea for Fibonacci's method is to subtract off the biggest fraction you can, so that hopefully the piece that's left over is like a unit fraction is the idea. Okay, so trying to see if this is, never mind. Okay, so we want to subtract off the largest unit fraction is the idea. So for example, if I had 6/11, is that a fraction bigger, or what fraction is that really close to? How about that? If you were gonna like approximate that and say that's about something, what would you say it's about?
Fraction?
1/2.
1/2. Yeah, wait, isn't this close to 1/2? Huh?
Yeah.
Yeah, because 6/12 is 1/2. How close to, is it bigger than a half or smaller than a half?
No, bigger.
It's bigger than a half, right? Because a half of this would be like 5.5 on top. So this is actually bigger than a half. So Fibonacci's method says, take your fraction of 6/11, subtract off a half. And the reason why I subtract off the half is because that tells me later on, my answer is going to be 6/11 equals 1/2 plus the leftover here. Okay, so when I subtract off, I got to get a common denominator or do it in your calculator. I don't care how you do it. But you get 12 over 22 minus 11 over 22. I just got a common denominator. Multiplied this one by 2 on bottom and on top. This one by 11 on bottom and on top. To get a common denominator, yeah. And 12 over 22 minus 11 over 22 is 1 over 22. So the piece left over is 1 over 22. And that's your answer. That makes sense? Okay, so the hard part is, what do you subtract here? Okay, so that's the tricky part. So let me show you how to do that. So 3/17. Let me show you how to do it with this one first. So the way that Fibonacci's method has you do it is take this to figure out what the biggest unit fraction is close to. Take this, and instead of making it into a decimal, because like right now, if I took this to my calculator, I would be able to do it, right? 6/11 is close to 0.5. I know 0.5 is the biggest, so 1/2. The problem we come across is, what if I have 179 divided by 1459? Do you know what the biggest unit fraction to subtract out of that? Even if I make that a decimal, do you know what the biggest unit fraction is close to that? 1.1226. Da, 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 da. Yeah, I don't know. Not a third, not a fourth, not a fifth. Like, it's a lot of thinking. So a faster way to do it is to take 6/11. And the idea is I'm trying to figure out 6/11 is in between which two unit fractions. What you can do is flip it, because the fractions is what makes that confusing. Let's turn it to whole numbers. Let's flip it. 11 over 6. 11 over 6 is the whole number, like is a fraction in between which two whole numbers. What's 11 divided by 6? 1 point something, not 2, because 12 divided by 6 is 2. So it's in between 1 and 2. Agreed? So when I flip it back, it's not in between 1 and 1/2. You got to switch the positions. I flip it back here and it's 1/2 here. I flip this and it's 1 there. It's in between 1 and 1/2.
Couldn't you do like, it's between 6/10 and 6/12? So just like take away 1 on the bottom and add 1 on the bottom?
For this one, it works because 6/12 is a unit fraction, but that doesn't work for all of them. Because if this was 6/121, it'd be 6/120. Oh, that actually still works. 6/73. It'd be
I was
6/72.
thinking if you have an even number on both sides, then you can reduce it.
Yes, it's just, like, this problem is fine because we started off with something really, really easy. But most of these, the unit fractions in between, it's hard to find them because like if you just subtract off 1 or 2, you don't get unit fractions on either side. Does that make sense?
Yeah.
Let's do some of them and I think you're gonna kind of see a little bit. So like the first problem, let's do 3/17. So trying to figure out the biggest unit fraction that you can subtract out of that. I'm trying to figure out 3/17 is in between which 2 unit fractions. If I subtracted off 1, 2/17 and 4/17, that doesn't tell me a unit fraction. Does that make sense?
Well, I was saying to subtract 1 on the bottom, so it would be 3/16 or 3/18.
Oh. And so then you'd get 3/16, 1/6.
1/6.
And so then honestly, whatever it takes to do it. This is like a fast way that you don't have to, I'm not saying you don't have to understand fractions, but it's like a fast way to get you every single time without having to think too hard about it. I don't care how you get the unit fraction, but the idea is we want to pick specifically a unit fraction, so it's a part of my answer. And I want to pick the biggest one so that the piece left over might actually be a unit fraction. Does that make sense? So it's your choice on how you figure out what that unit fraction is. So figure out the 2 unit fractions this is in between. One way to do it is to think about it in terms of whole numbers. 17/3 is 5 point something, because 18 divided by 3 is 6. So this is 5 point something. So that's in between the number 5 and 6. That tells me this fraction is in between 1/6 and 1/5. Why do I have to like switch them when I flip them? Any idea? 6 is bigger than 5. Is 1/6 bigger than 1/5? No, when you talk about fractional parts, you're kind of going the opposite
So you
direction.
do the reciprocal
Mhm.
whenever, no matter what.
Yeah, just because it's easier to think in terms of whole numbers. Would you agree? So it's easier to think about this in terms of whole numbers, but when I flip it back,
Well, I just think like whenever you put 6 in there, it's gonna be the reciprocal. which
yes,
is-
yes, it's always the reciprocal and you always switch positions. So the biggest fraction I can subtract off is always this side. 1/5 is too big. I can't take away 1/5 from that. So however you get 1/6, totally up to you. So I can subtract off 1/6. And like some of these, it takes a few steps. Go ahead.
How do you know whether to choose between 1/6 and 1/5?
Because my number is greater than 1/6, but it's less than 1/5. If I subtract off 1/5, I'd get a negative number for my answer. So you want to pick the smaller fraction, the one on the left always. For me personally, sometimes I start losing track of what I'm doing and like for my answer. So for me personally, I have to like keep track of it at the bottom of where I'm going to write my answer. And I have to say I'm subtracting off 1/6. So 1/6 is a part of my answer. And then I continue. So feel free to do that. You might have more brain space than I do. I just feel like I don't have enough room in my brain sometimes for these problems. So I need to get a common denominator or do it in your calculator. I don't care how you do it. I'm gonna get a common denominator and I get 18/6 times 17, 102. Minus 17/102. And leftover would be 1/102, which is a unit fraction. So my answer is 1/6 plus 1/102.
We doing homework or we can use whatever.
I'm gonna make you do both. I'm gonna make you do one of these and one of the other. And the other, you can kind of choose if you want to do 1 + 1 + 1 and break them all apart, or 2 and 3 or whatever.
Let's do one where your answer is not a unit fraction.
Okay, so let's do one that it's more, your answer has more than 2 fractions in it. So if we had the problem 5/32. Figure out which unit fractions on either side. So if you do the reciprocal thing, 5/32. If you flip it to get a whole number, 32 divided by 5 would be 6 point something. Yeah, it doesn't even matter. Like, you don't actually have to know what the decimal part is, right? We just know it's in between 6 and 7. So my fraction is in between 1/7 and 1/6. You got to switch them every time. So what's the biggest unit fraction I can subtract off? 1/7. So I'm going to subtract off 1/7. And for my head, I'm going to come down here and say 5/32 is 1/7 plus whatever I get here. So when I get a common denominator, feel free to do this part in your calculator, I don't care. Would be 35/224 minus 32/224, which leaves me 33. Nope, try again. 3/224, which,
You have to do it.
yeah, that's not a unit fraction. So at this point, I'd check and see if that reduces. I don't, 8, 9, 10, 11, 12. Wait, it does reduce. No, I can't add 4, 5, 6, 7, 8. It's 8. So yeah, this does not reduce. If it did, that would be amazing, right? This is not reduced, so I have to do it again. You have to subtract off the biggest unit fraction from that. So now I'm going to have 3/224. I'm going to do the same process. So 24 and 25, 24,
74 and 7.
74. My 2's look like a 7, so that's fine. 75. So the fraction 3/224 would be between 1/75 and 1/74. So I want to subtract off a 75th this time. And so this is the point where I get lost on my answer when I go to write my answer. So like, this is the point where now I know this is a part of my answer. I need to write this as a part of my answer. 1/75. And then when I get a common denominator. Oh, no, I did that wrong. Times 75. This is times 224. So I would get 225 over 16,800 minus 224 over 16,800 leaves me 1/16,800. So my answer would be plus 1/7 plus 1/75 plus 1/16,800. If you would prefer,
It's not associated with the Egyptians.
no, it's Fibonacci.
So someone else.
Yeah, this is like 80. So if you prefer at this point, when you get to this number right here, you can continue this method, or if you wanted to break that down a different way, using like the splitting identity, you could do it that way
What
also.
was the purpose of getting unit fractions for Fibonacci? Like, what would be the purpose of needing it? Just for fun?
No, because I learned this in math. I'm trying to think when you actually, never is when you, I'm joking. I mean,
I know the Egyptians did because they.
right, I agreed. So here's the thing you'll learn about me as we're going through this. I am not a questioning person. So unless it's been taught to me, I don't question it, but it's great for you to make me question things. Why do we need to decompose fractions? Like a common thing that we, like, I had to learn about it in my math classes. Oh, here we go. I don't know. I'll come up with an answer next time.
Okay, I'll show you later too.
Because the things I'm looking is in fourth grade for kids. Like, that's not what we're looking for. So your homework today, let me show you the homework. So, it is under week 3. It's called Egyptian math homework. Because I was trying to come up with like operations and fractions or, whatever. So I just called it math. So all of number 1, 2, A, B, and C, 7, and 12. And here is the textbook. So all of number 1, so that's multiplication. 2, A, B, and C, that's division. What was next one? 7 and 12. So number 7 has 3 fractions, and you're doing them both ways. Splitting identity, Fibonacci's method. And then 12, we haven't done 12 yet. We'll do that next time. So this is the homework. Questions about that at all?
I have a question about the last homework that's due today.
Okay, let's do it. It's under week 2, right? This one, the cuneiform. Yeah. Right. Which one?
So 2C,
Mhm.
that's supposed to be 2, comma, 26, comma, 1, comma, 1, 52, comma, 31? Or is
Mhm.
that like, is it supposed to be 2, comma, 27?
No,
Like, that's a whole lot of commas.
I agree. I see what you're saying. That should be 27 because
Okay.
that should be down here. I'm wondering if, like, for whatever reason, they couldn't put it in that form, but yes, make that 27.
Okay, so it has 4 place values, not 5.
Yes. Yes, 1, 2, 3, 4 place values. Yes.
Okay. And then on the number 5, because we only have to do 1 through 5, right?
Yes.
Do you just, when you multiply by 60, are you just putting a 0 in like what we would consider the tens place? So like you just adding a 0? So
Kind
if you
of.
multiply by 60, it would be 12, comma, 0, comma, 3.
No, it would be, let me do this, 12, 3, 45, 6. Let me just do 12, 3, 1. How about that? Just make it a little bit easier. 12, comma, 3, and then 1 like that. So if that was the situation, this would be 12 over 60 to the first power, 3 over 60 to the 0 power, and 1 over 1/60th. So if I multiply everything by 60, I can multiply by 60 up here, but then it's going to bump over. So the idea is like this now turns into 60 to the 0 power. This turns into 60 to the first power, and this turns into 60 squared.
So you're essentially just moving the decimal to the
Exactly.
right?
To the right, correct. It's the same idea with our system. If I had the number 1, 2, 3, 4, and I want to multiply by 10, the idea is I take my decimal and I move to the right. And it becomes 1, 2, 3, 4. I put a 0 there. You know what I mean?
So then if you did it by 60 squared, you'd move it twice to the right.
Twice. Huh? Uh-huh. I think a better example instead of 1, 2, 3, 4, if it was 1, 2, 3.4 and I multiplied by 10, I just move my decimal over one time. So it's the same idea. Here we're multiplying by 10 in the base 10 system, and here we're multiplying by 60 in the base 60 system. Does that help?
Okay. Yes.
Anything else? Okay, we will pick up next time with some more Egyptian stuff, and I will